Thank you, everyone. And so we are Dragon team, come from Drexel University, Lebel College of Business. My name is Ran, and these are my teammates Arjun and Hong. Today we are going to talk about how we help Syngenta select its elite varieties and to meet its commercialization strategy. Syngenta, one of the world's leading biotech company, is now facing the challenge of determining commercial seeds which should perform to customers' expectation. Why is an outstanding seed selection strategy so important to Syngenta? Because it will not only help Syngenta to maximize its business impact, including reducing the costs or improving the sales performance, but also it will increase the social benefits, especially to the farm sector and food industry. Ultimately, a higher productivity and a lower price will benefit the end customers. So now what we need to do is to select the elite seeds to commercialize and identify the seeds potential sales of the future varieties. And based on this, we will give Syngenta a practical recommendation. To achieve these objectives, our unique contributions is the first one is we constructed new features to better extract the information. And then we using different predictive models to get a robust results. And based on this, we will give Syngenta a unified seed selection strategy which they can use in the future. After we have figuring out our objectives, let's take a look at the provided data and the facing challenges. So in our historical data set, we have more than 250,000 observations, and among them, there are around 15,000 unique soybean varieties. For each of the observation, we have 12 variables, and these variables can be separated into numerical, categorical, and logical data. Since we want to predict the sales of the varieties, so first take a look at if there is any relationship between the sales and the other numerical variables. But however, eyeball these graphs, we can see there's no straightforward patterns between relative maturity with sales or the yield and sales. Apart from no straightforward patterns, we have only 0.2% of the varieties with the sales record. And within these 33 varieties have sales record, we only have 6 identified as elite varieties. Moreover, we have a lot of missing data for varieties not following the 3-year test. So all these difficulties indicate that it's hard to predict the sales potential or identify the elite seeds directly from our historical data set.
So now that we have looked into what our challenges are, let's see how we came up with a solution for this. Our key contribution comes from feature construction. In order to basically condense majority of the historical data, genetic traits, temporal trends, and how a variety performs over several locations, we created 4 categories. The first 2 categories here are basically static in nature. The family traits and the variety traits basically try to capture how a variety performs and a static nature. We compute 3 features here: the average yield, the median yield, and the standard deviation of the yield, which across all the years and all the locations. Similarly, we find the specific family for that, and then compute the other 3 features. Let's take a look into the more dynamic natures now. In order to identify how a variety performs over several locations, we computed the standard deviation of the average yield across all the locations for a variety, just to see how it performs over several locations. Similarly, we do this again for the family. The last category here, the temporal trends, we try to identify how a variety performs over several years by computing the correlation year over year and the residual errors to identify fluctuations within the yield. As an example, for this particular variety, we can see that as it passes through several stages of locations and years, we basically get the 58.3 mean yield for this particular variety. For a more dynamic metric, we can see we average the yield for 2011 and so forth and compute the 81.04% correlation. And to further visualize this, we can see that this variety is an elite variety having more than 1 million sales, and we can see an increasing trend that shows that it's increasing in performance. Let's look into how we dealt with missing data now. In order to, since our data had a lot of missing values based since varieties were not tested for multiple years, we basically predicted an estimate for the correlation and the residual errors. For correlation, we used the 640 varieties, which had the data available, and we used stepwise regression, which led us to choose relative maturity, spatial stability by family, and the median yield by family. For residual errors, we utilized 139 varieties and all features except for correlation.
So after constructing 10 new features and fixing the mixing value problem, now we can go into use those data to build up the predictive model. So basically, we have two data model in here, classification and regression. We use two classification models, support weather machine and random forest, to help to predict if one variety should graduate or not. So then we use multilinear regression model to predict the sales volume, or you can say the sales potential of one seed. Then we will know what exactly it will be if we put it and sell it into market. So let's talk about a grouping process in the classification model. We have two classes, graduate and non-graduate class. So you can see the graph here. Basically, we have two types of variety that would be considered to stay in the graduate class. One is the Drexel, variety that have Drexel volume higher than 1 million. But basically, that means they're elite varieties. Of course, we should let them graduate. Another type is the benchmark variety that is mixing their sales data. Therefore, we all know that the benchmark variety would be selected as a check variety is basically because it has something out better than other seeds. But since they're lacking some sales data, we can't deny they have the potential to graduate. So we just decided to keep it in the graduate class. And the rest seed would be considered as non-graduate class. So now we can talk about the first classification model we built, support weather machine. Basically, it's a method trying to find out the optimal hyperplane to separate two groups by maximizing the distance between two groups. So you can see this graph here, two-dimensional graph here. Actually, it's trying to find out a line to separate the star and the circle. So the reason why we use SVM is that you see the concept under the SVM finding the optimal hyperplane is really easy to understand and to implement in R. Another reason that, remember, we talked about in the data challenge part, actually we didn't see any clear patterns within the features. So what we use as VM is because it's really flexible. We can change objective function by introducing some penalty function, or we can change the constraint into linear if we find out more information to support these nonlinear patterns. So the best support weather machine model we're using here is the one with 9 features and utilize 109 variety that reached the final stage of the class of 2011 to 2013. So basically, these are the varieties that reached the final stage before commercialization. So now we can use this support weather machine to determine which seed should graduate. So unlike SVM, random forest is more focused on identify the graduate class directly. So actually, it's a supplement to the SVM model. So also, you can see the graph here, and the random forest is trying to take advantage of the multi-backend classifier and get a robust result based on the majority vote. So that's basically the 3 reasons why we choose random forest. The best random forest model we use also using exactly the 9 variable that in the SVM. But what's more, it covered all the varieties except those class of 2014. So in this way, 315 of them are in the graduate class. Now we can use the random forest model to determine which seed should graduate.
So now that we've looked into how we utilize the classification models to select particular seeds, let's look into how we identify the sales potential utilizing multiple linear regression. The variables that we used here were family variety, variety traits, the temporal trends, the spatial stability, and relative maturity. In order to identify the best suited model for us, we first look at if there's any outliers within our data, identify any insignificant features, and utilize stepwise regression. As for the training set here, we have 33 varieties, with the range being 14,000 to about 1,865,000, and with the mean being about 588,000. As you can see from this plot, when we plot standardized residuals by the predicted sales, it's clearly one outlier within our data, and the Cook's distance validates this. So we choose to remove variety 156247 from our data set. Now let's look into how we decided to select the best regression model. Regression 1 included all 11 features, regression 2 included 6 features, and regression 3 included 8 features. Regression 1 was found to be insignificant based on the p-value, while regression 2 and 3 were significant. When we look at the R-squared, they're pretty similar to each other, and as we remove 2 variables from regression 8, which is standard deviation of the family, and the residual errors, we find that the R-squared only decreases by less than 2%. And thus, we conduct an ANOVA test between them, and we find out that there is an insignificant difference between them, and this validates our selection for picking regression 2. As per our results, we find out that the sales potential can strongly be predicted by the relative maturity, the correlation year over year, and the median yield of the family. Again, now we check to see if there's any other outliers, any other extreme cases within our data, and we find out that there's no clear pattern and there's no unusual residuals whatsoever. So now that we've understood how we build our models, let's look into specific results that they gave us. As for Syngenta, they're basically aiming to commercialize 15% or less than 15% of seeds for each batch. For 2014, we were given 38 varieties. So that basically means we're looking to perhaps commercialize 5 or less than 5 varieties. For SVM, we find out that 20 graduate varieties were identified, with some insights about them being the relative maturity goes from 2 to 3.9, and the median yield of the family is about 55 to 70. For random forests, we find a similar pattern. We identified 7 varieties, and the relative maturity is similar, except the range minimum is 1.5, but the median yield family stays pretty much the same. For regression, we actually identified 5 varieties, which meets the selection criteria, and we can see that the total sales potential here for the 5 varieties listed is actually 5,450,000. As you can see from the chart on the right, it basically shows that in the past years, more varieties were commercialized, and some were not as profitable, so the average sales potential has been on a decline. But if we utilize these results, we can see the average sales potential increases tremendously.
So after analyzing our results, here is our recommendation. First, we suggested Syngenta to use a 3-step process to select its elite seeds. So first, we can use classification to identify the graduate seeds, and then we use regression to predict the sales potential. And finally, we find the intersection of the model results. Specifically, the first priority will give us the best seeds to commercialize. And in our evaluation data set, we can see there is 2 top seeds has been selected. And if we want to increase variety diversity or decrease or distribute the risks, we can use the second and third priority to select more seeds. Second, we suggest Syngenta to create a more rigorous testing phase, and it will help us to filter and evaluate the varieties based on 3 main attributes. Take the family genetics, for example. It will require the median yield of the varieties family should be larger than 60, and the relative maturity should be in a range between 2.5 to 4. And for the correlation, because the selected seeds should have an increasing performance, so it requires the correlation should be larger than 65%. In conclusion, we use classification and regression models to get an improved elite variety classification and reliable sales prediction. And we suggest Syngenta, when they select the best seeds, they can focus on the key attributes we get it from our model. They are family genetics, temporal trends, and the relative maturity. But in this stage, we didn't consider about the marketing costs and other costs, or the competitors' strategy and performance. So these are all the things we want to share with you today. Thank you for your attention. Any questions?